Good afternoon. Can you hear me clear in the back? Okay. So, even though you are a global business partner, over 95% of you are located in India. And you know what has happened in India recently? We have a new government, and the new government has a big mandate to do what? It is building a new infrastructure, 100 new cities, new education. Why? Because infrastructure matters for national outcomes. You want good quality graduates, good talent pool, you have to invest in it. You want a good transportation infrastructure, you have to build new airports, railways. So it goes without saying that infrastructure is important. Equally, infrastructure, but of course, in the context of a business, we talk about IT infrastructure because businesses are automated. So it goes without saying that infrastructure matters for business. And I'll also give you an example, once again using a physical world, on what happens when you don't have the right infrastructure. How many of people are you from Bangalore? Bangalore was a retired person's heaven. When I was born and grew up and educated there, it had a laid-back infrastructure. Subsequently, it became the Silicon Valley of India. And those of you who live in Bangalore know that the infrastructure, especially for transportation, or a whole number of other things, is holding us back. I'm not blaming, I'm not complaining, but I'm illustrating what happens when infrastructure does not match the outcomes expected. The same is true here. So it's not so much whether infrastructure matters or not. It matters, but what infrastructure matters? And that's what we're going to talk a little bit about. A number of people have made the point. Esther said it very well. Future business models are being defined by cloud. Partly because businesses are counting on it. 85% of the applications that are new are being developed on a cloud. Gartner expects, or IDC expects, I don't remember which one, by 2016, 1/4 of all the applications will be on cloud. In the world, the interaction is no longer a PC, it has already been supplanted by mobile. And as Dieter pointed out, there are people collaborating more on social business. However, in the business part of the world, it is growing. Gartner says by 2016, 20% of the businesses are going to do not email, but more social networking to communicate. And of course, as Esther pointed out, the competitive advantage comes from analytics and getting value out of it. And the good news, 2/3 of the businesses understand this, 1/4 of them are already doing some sort of a proof of concept and have a plan. And this world, which produces the value, connects to the back-end systems of record, and has a new way of engaging, is something that is not just an IBM phenomenon. IDC calls it the third platform. They say the first platform was the mainframe. The second platform was the client server. And the third platform, they don't give it a name, we give it a name, IBM, CAMS. And IDC basically estimates that between 2013 and 2020, the only platform that's growing is the third platform, 11.7%. Distributed client server is growing 0.8%. And also, if you listen to IDC, there's a whole lot of things in here, including the millennials, the new breed of customers, the CMOs, the chief HR officers, as well as the CFOs, the new breed of clients. The millennials with expecting response consistent with the demographic of one, something that is personalized to that instantaneously. There are a number of things that are happening, but IDC says the number one reason for business transformation is client experience. So client experience, new breed of clients, and the change of all of this. That's what's defining the new era of computing. And Dieter already mentioned that the IT infrastructure that is already creaking is now overwhelmed Right? We'll take a little bit more look at that. We have always understood that there has been a gap between what business expects and what IT provides. Businesses want competitive advantage, revenue, profit growth, and IT needs to be supporting the capabilities for big data analytics, social media, cloud. However, if you look at the problems that IT faces, it has remained the same. 70% of a CIO's budget goes towards keeping the lights on, existing infrastructure, continued maintenance of it. And by a recent study that we have done, worldwide data centers, where the definition of an efficient data center was if more than 50% goes towards creating new capabilities, by that definition, 80% of the data centers worldwide are not efficient because they're spending most of their money on where they are. So the situation is we don't have an adequate infrastructure. I gave you some real world examples, physical world examples. There is a new things coming at us. And how many people have heard Einstein's definition of insanity? It is doing the same things again and again, expecting different outcomes. We cannot afford to do that. What we need to do is to find and go towards where the new infrastructure is. Now, before I get to what the new infrastructure is, in addition to supporting the CAMS, the software-defined environment, which we'll get to, let me just amplify a little bit more on what Esther pointed out. IBM has this Institute for Business Value, where we recently completed a study of 750 organizations, out of which about a couple of hundred CTOs, a couple of hundred CIOs, the rest IT executives. And what we looked at was to try to find out what are the trends, what are the challenges, what are the best practices, and how do these people differentiate their business by asking a number of questions, including how ready is the infrastructure for the new world, what are the top business and organizational challenges, how is IT perceived, and what are some of the cross-organizational collaboration issues. And Esther already pointed out, most people know that IT is expected to provide the capabilities for optimizing the business outcomes, the revenue, profit, and competitive advantage. However, less than 10% are fully prepared to go into the new world of CAMS. But if you look one step further, it also gives a little bit more clue on what we need to know. So in the study, we had looked at 5 attributes that define strategic IT thinking. 1, there is an end-to-end IT infrastructure in place. 2, IT acts as a technology collaborator. IT acts as a technology broker of services. IT collaborates with business, and there is cross-functional capability, cross-organizational enablement and collaboration. And the last one is well-defined performance measures in place. If all 5 of them were in place, we can at least 3 out of 5 were in place. We said the IT is considered strategic for the business. And then we looked at the rest of the stuff. Number 1, for companies that had IT that was strategical to them, by the metrics that I mentioned, they outperformed their peers on revenue, profit, and net profit margin. 2, as this chart shows, they are in a much better position to cope with the infrastructural demands that are being brought forward, which we will once again look at a little bit more in depth. However, just like the data center study that I mentioned earlier, the strategic IT organizations were only 17% out of the 750 organizations that we looked at. So this is a rarity. So our point of view is not only just the right IT infrastructure, it is a right IT infrastructure strategy is essential for achieving the business outcomes. And part of that is to essentially be able to enable nearly all the workloads for cloud and ensure the right time decision making. We'll see several examples of this, but fundamentally, it is by connecting what Dieter mentioned as the systems of record, existing enterprise systems, to new ways IT is going to be engaged, systems of engagement, connecting them, taking advantage of the data, and being able to use the data for competitive advantage, but be able to make decisions on that in the right context at the right time. And IT infrastructure has to be optimized so that rebalancing of investments can be made so that the new outcomes, the new world can be accelerated much more. And automation of the capacity, dynamic services delivery, orchestration, provisioning, etc. to enable that, and the right tooling. These are all things that are part of the overall IT infrastructure strategy. So let's go through each of these a little bit and see what is involved. For cloud, improving the economics of IT through efficiency is a paramount need. So that costs can be decreased, so that operational costs can be decreased, and therefore new client services can be enabled. So efficiency matters. And for cloud, the new breed of systems of engagement do not necessarily have the same high qualities of service that traditional enterprise systems, systems of record, have today. And yet, it is necessary to integrate the two to provide an end-to-end rich client experience. And in doing this, it is extremely important to make sure that there are no compromises, because the integrated experience, going back to what IDC said, the number one need for transformation is the client experience. If that's important, and if the new client experience is going to be provided by the integration of the systems of engagement with the systems of record, then there is no room for compromise for what business operations have to be done. And the last one, and therefore resiliency matters. And the last one is responsiveness. Agile IT, to bring out cost competitiveness, new capability, so that new business outcomes can be enabled quickly and consistently. And that is the responsiveness. So responsiveness matters. So let's take a look at each of these attributes, and I'm going to illustrate them with the help of client examples. First one, efficiency matters. In order to be efficient, there has to be consolidation. The infrastructure, IT infrastructure, has to be virtualized, and it has to be optimized, and it has to be simple to manage. And I'm going to give some examples, not necessarily all the examples. Once again, I'm just like Dieter, I am from the systems part of the business. I'm going to try to stress some of that, but I'm also going to the bigger part, which includes the rest of the system stack as well. Dieter already pointed out that our point of view is we need to enable this with the help of open technologies. So things like OpenStack, things like KVM for virtualization, these are very important. And we need to provide these standards, and we need to be building the interoperability on the basis of that. We also expect that one platform, however powerful, is not going to be able to build across all of them. And therefore, having multiple platforms and being able to provide cross-platform virtualization and management, that's important. While much of today's infrastructure has been built painfully, painstakingly, over a period of time, building optimization and how to make it work, we don't have the time to do that for the new breed of workloads in cloud. So it has to be through capturing the best practices through and deployment of patterns. And as we go into virtualization, we cannot afford to make the physical hard to manage. So integration and simplification of the virtualization management, virtual as well as the physical infrastructure, that's important. Now in the area of resiliency, as I pointed out earlier, systems of engagement and systems of record, interconnected, they produce the client experience. And we need to be able to extend the qualities of service, the consistency that we have built in the back-end legacy systems or systems of record to the integrated new version of systems of record and systems of engagement. And what we have built in terms of the workload optimization for the enterprise systems, we have to be able to accomplish that in a much less painful, much faster way in the systems of engagement as well. And that is through the software-defined environment. So our learning basically says that in order to get to resiliency, there are a number of things that we got to do, and those are listed in here. Being able to avoid failures, being able to provide continuous scale, being able to add capacity without requiring the systems down, etc. And responsiveness matters. Being able to get to value, time to value very quickly. Clearly, we already talked about patterns a little bit. Get to the end value quickly. Self-service and automated provisioning are important. The integrated infrastructure, network storage, and multiple varieties of servers and different varieties of storage. Integration and managing them is important. And a set of tools that will allow for public and on-premise applications or private cloud. It's important, and you're going to hear a lot more of that when some of these things are discussed in later sessions. So, a quick word about the software-defined environment. One of my colleagues, Matt Hagstrom, the CTO for software-defined systems, is here. He's going to go drill down into a later session on software-defined environment. But the problem that needs to be addressed is what I'm going to talk about here. In the traditional enterprise systems, we have taken a bottoms-up approach. Hardware, firmware, operating systems, middleware, and created a level of optimization. And that is for specific set of workloads. That workload capability, while it takes a long time, it has served the optimization very well to reduce the overall cost of computing. We cannot afford to do that in the same fashion for the new breed of workloads, where you have to have agility, but you can't give up on optimization. And the expectation on how you do that is by having a virtualized infrastructure, and having that virtualized infrastructure take advantage of open source technologies like OpenStack and build essentially a modular, standards-based way of putting together a new stack, and having that new stack perform as close as we can to the optimization that we achieved. And by the way, we know how we achieved the optimization in traditional systems. And that is done at every layer by having a set of monitoring capabilities and reflect what is going on in each of those layers, so that at some overall bigger picture level, where there is an understanding of service level agreements, you have an expectation of what is needed versus where we are, so that the difference can be used to drive additional resource, so that workload aware systems, resource efficiency can be built in, and very quickly, under automation. And that's essentially what we want to achieve with the software-defined environment. Bring the workload optimization capabilities that we have built, but using different set of open standard interfaces in a new world. And by the way, that will allow us to support both public as well as private clouds. Let's take a few customer examples. TraxPay is a financial services company in the United States, in California. The problem that they addressed was their customers were experiencing significant delays in processing payments. They have performed a service, but taking hours to days in order to get the money introduces two problems. One, it introduces a cash flow problem. The second, you lose interest on the money that is owed to you. So what they wanted to do was to build a private cloud. And they built the private cloud for doing these real-time, these financial services in near real time, so that they could actually start small, grow big. That was one of their needs, so that they could do this with 1/10 the cost that they would have done with the traditional way of doing it. And by the way, they did this with a Linux on the mainframe with a software stack that also includes IBMs. So an example of how efficiency did matter to them. A second example is the All England Lawn Tennis Club, the people who put Wimbledon together. Now, there are an estimated 800 million tennis fans all over the world. Only a few 100,000 can actually come, participate physically in the Wimbledons. So, and by the way, the clientele is a sophisticated clientele. As many of you probably know, I don't know how many of you play tennis, tennis is not a poor man's game. It requires a fair amount of infrastructure. These are well-to-do people who are upscale. They are very sophisticated. They had already been connecting into the Wimbledon tennis website. And what we had seen was by 2012, 40% of the websites were using mobile devices. And there were mobile apps downloads were doubling. So in 2013, what IBM did, working with the All England Tennis Club, was to essentially leverage mobile as well as social capabilities to the event, so that combining it with significant amount of analytics, so that the sophisticated user base could virtually participate from wherever they are using their mobile devices for a better user experience. This was done by the InfoStream stack along with a series of power systems. The next example is a European company who provide computer services. And their goal was to provide storage services using a cloud. And to be able to do that so that the provisioning and the usage of these in a self-service capability was very quick. And as I mentioned earlier, in order to have self-service capabilities, responsiveness was very critical. And what they were looking for was the ability to provision storage servers in essentially 30 seconds and getting it to access of the files in 15 seconds or less. And they were able to achieve that with less than 2 months of work. So these are some highlights of customers who say that, number one, these things can be done. And in today's stringent requirements, they are doing that with us. Big data and analytics. The essence of big data and analytics is to be able to get a new level of visibility, intimacy about customers or a company's operations. And to do that, whatever is the relevant information that is required has got to be accessed and has got to be used. So that's one part of it, and therefore access matters. The other is, this is about speed. When you have the aha moment, or when you are at the aha moment, we're going to see some examples of this, it is important to operate on the insight that has been gathered about a client or the operations. Because the point of analytics is not the insight. The point about analytics is using the insight to make something happen. And that typically involves integrating two different kinds of workloads. Operational workloads are today's systems of record kinds of workloads, and big data analytics produces a level of insight that needs to be combined and applied to the operational workloads. So in doing that, the integration and the speed by which that is done matters, as well as the speed with which the insight is gathered and provided also matters. And availability matters. Because the whole point of this is to empower the clients who face, empower the people who face the clients, and provide them the right level of information so that they could act on it. If you have a customer-facing person and a client calls him, irritated about having had their calls dropped 8 times in the last 3 days, or call failed message. I'm not going to go talk about that in here because I'm sure that every one of you has experienced that in the India context. Call failed, you cannot make the call. And you get irritated and you call your service provider. And if the service provider knew that they had dropped your call some number of times in the recent past, then they could, at the point of the aha moment, they could offer you something that will appease you. And I won't go into the scenarios because there are a number of them using some of the solutions that we have been developing, but you get the picture. The key point, though, is to be able to get consistently that kind of insight delivered to the client-facing people. Because if that insight delivery is not there, then it is as bad as having the calls dropped. You don't make much progress. So let's look at each of these characteristics a little bit. Access matters. This is a matter of taking the structured data as well as the unstructured data. And as you know, the unstructured data has been growing at an enormously rapid pace. And a number of things that matter. Obviously, enormous amount of data, therefore scalability matters. And by the way, when IDC recently met in one of our conferences where I was at, right, the number one point that they made in the India context, which is somewhat different from the global context, is getting a single view of the data, the master data management in India is one of the most important things that they need to get started with. That was their observation. Now, in addition to that, the efficiency of virtualization and the resource management, how optimized is the data storage and the data accesses. We'll talk about that in a little bit more. And how optimized is the compute. And in the compute optimization, threads matter. For example, in a highly data-intensive environment, the I/O bandwidth matters, memory bandwidth matters, hardware threads matter, parallelization matters, and some of these matters even in the case of the cloud, especially if you're doing an analytics workload being delivered over a cloud. But especially in the big data analytics space, these things matter a lot. And when you have a large amount of data, not all of them is going to be tier 1 storage, and therefore having different data tiering that matches the cost and the performance characteristics and being able to move that automatically, that matters. These are all things that are very, very important. And single view of data and master data management, as I kind of emphasized right in the beginning. Now, for the speed, once again, similar things are important. Parallel processing, and you're going to see an example very soon of being able to get to very large amounts of data with a very low latency, such as flash. Scale in, scale out, scale up architectures of this kind. And being able to use various appliances, integrated workloads like the data analytics accelerator in the case of the mainframe, specialty engines, ways to add compute capacity that doesn't defeat the rest of the economics of the system. These are all important things for getting to speed. Availability. This is where you actually act on the inside. And therefore, from the time you get the data lifecycle management, from the time the data exists, operational data, warehouse, making a copy, being able to do the analytics on it, generating the insight, and operating on the insight in an operational systems context. This needs to be as quick as possible because, as has been said in many of our strategic thinking conferences, you can't afford to take data to analytics. Analytics has to come to data. Because data, once it gets refreshed, first of all, enormous amounts of data going through the network is a huge performance impact. It creates a lag in the data, therefore a lag in the insight. So for a whole bunch of reasons, optimizing this overall path becomes very important. And the traditional kinds of approaches for accessing data in the event of failures, data recovery, self-healing capabilities, and continuous management and access to data all over. So these become important capabilities. So let's take a few examples. The Bank of Guangzhou. Right? Today, if you are a banking CEO, you have a few top-of-the-mind issues. One is return on investment, because there are an increasing number of regulations that are happening to a bank, anti-money laundering and a whole bunch of others. And they cost money to the bank. And yet at the same time, the traditional banks are competing with the new breed of people who provide transfer of money for payment of services, whether it be Alibaba or a number of other new breeds. And they are not subject to the same regulations that a traditional bank is. They got to compete with them, with their hands tied behind their back. And banks are losing trust. May not be necessarily in India, but globally. Because the end customers are not identifying with them. Part of it is being the millennials. And banks have traditionally offered products that are product-centric, not customer-centric. If I am a customer, if I'm going to be a demographic of one, I don't want the bank to know what my mortgage application is, independent of my loan, independent of my boat or car, independent of my insurance, independent of my wealth management. They need to know all of them put together and get a holistic view of me and tell me what would help me make either wealthier or whatever the current problems that I have. And that's essentially what the Bank of Guangzhou ended up doing. Using Cognos and using a power system, they were able to put together a holistic view of the investment habits and the banking habits of their wealthiest customers. The result was a 150% increase in the high-value business customers. Coca-Cola Bottling Company. These folks are part of the supply chain. And in a supply chain, being extraordinarily efficient and timely is very, very important. Because excess inventory, you pay. Under inventory, you don't get enough money. And they were doing prediction of forecast. Prediction of demand or forecast. And they wanted it to be much more granular. And they improved it through a better model. However, that introduced a very significant time for crunching this, the data that was involved in it, 14 hours. And yet, their problem was knowing what they sold today, they need to be able to dispatch their trucks with the right place to the right events, with the right content in the morning, the next morning. So they could not take this 14-hour window. So what they ended up doing was to understand that the data access latency using the traditional I/O infrastructure was the problem. And by using flash technology, they were able to reduce the data improvement, the data reduction time by 20x. And that resulted in getting the insights about what they should be doing, customer demand and delivery, 4 times better. Sui Southern Gas Company Limited, Baluchistan, part of Pakistan. The problem that they faced was in the natural gas business, they're a natural gas distributor. In the natural gas business, there is ever-increasing demand, but the supply is very expensive to increase. So matching supply and demand, that was the problem that they faced. The second problem that they faced was in that part of the world, gas was being stolen. Just many of you probably realize that the same problems that the electric distribution companies in India faced. Essentially, unauthorized taps. And they wanted to minimize that because that was hurting the supply and demand balancing. What they ended up doing was to create a map, an overlay of digital maps with actual real-time operational financial data. So they could visualize what was happening in their business in pretty near real time, and they're able to do that. And that essentially, as the CEO comment here, right, business can now have the power to forecast, to test new capabilities and rapid changes immediately. So this is something that they were able to accomplish with visibility into their company's operations. Mobile. In the world of mobile, the number one thing is having the right availability of information for the right empowerment. That matters for better informed decisions. And security matters. Security of the transactional data, the operational data, which is extremely critical. And the last one is accelerating the time between the information access, analysis, and action. These things matter. So I won't take time through this because this is a similar kind of pattern. So number one, developing tools that seamlessly integrate data and transactions. Later on when you hear Bluemix, that's one of the things that we're going to talk about. Scale out infrastructure, multi-site geo-mirroring, workload management. Obviously, security matters. Securing the data, built-in cryptography, data and transaction co-location. This is important because, as I mentioned earlier, operational data traditionally has data governance and security. Applying the analytics to it and acting on the analytics, people typically do not put it in the same context. Integrating the two and co-locating makes a huge difference. And consistent data security data center. And of course, speed matters. And this is where the integration of the operational as well as the analytics with low latency, fast access to operational data becomes very important. A few examples, University of Florida. 50,000 students, 5,000 plus faculty members. They wanted to enable being able to do pretty much all of the university. They wanted to expose, and they have exposed all of the university resources using mobile devices to students as well as faculty. With the result, people can go do whatever they want to do wherever they are. I don't know if they allow you to take tests on that. That would be a tough one. But nevertheless, doing the usual routine transactions that a student has to execute, they have been able to do that. Done on the basis of a System Z mainframe. RCBC, a tier 2 bank located in the Philippines. They wanted to do the same thing that University of Florida did. Enable, do banking transactions, pretty much all the banking services using mobile devices. Once again, they accomplished that by a mainframe. Anthony Squires is an interesting example. They're an Australian luxury apparel retailer. What they ended up doing, or what they wanted to do, was, and they have done that, is when one of these high-end customers walks into a store and wants a garment, they don't have it. Enable, using mobile-based way of tapping into the inventory of other stores and the headquarters. So they could know where it is And while the customer is still waiting, they could allow fulfilling that particular demand, even though they did not particularly have it. So doing this increased their sales 16%. And they did that on the basis of a system I. So the last part is about security. Esther said it best. Besides the business model changes, besides the new way of engaging using mobile and social media, besides the competitive advantage provided by data, the thing that makes this all work is trust. And trust is heavily centered around security. And security, you can talk about that in 4 different areas. First one is making sure that you protect the enormous amount of data that is involved. The high volumes of data, the varieties of data. The second is the access to people, managing their identities and providing the access to information. How do you do that? And there are a few celebrated examples, like Target, who kind of failed at some of these things and had a huge worldwide exposure. And applications, making sure that the applications as well as the infrastructure, networking, storage, and other infrastructure, these are also secure. So I'm going to quickly flash through some of these things because most of you are familiar with the capabilities that are in the enterprise systems. End-to-end encryption, key management for encryption, as well as sensitive data transformation and masking. Being able to provide identity management, intrusion defense, fraud detection, and we do have a number of solutions. The point of this is it is not a single-dimensional technology. It needs a set of capabilities that are broad and cuts across, and by stitching these together into the right solution is what you expect to be able to do these things. So application and data isolation, user provisioning, fraud detection, vulnerability detections, access controls, comprehensive and consistent centralized poly for security intelligence. And many of the things that are being done, for example, IT analytics includes security so that more technology can help in the operation of the IT infrastructure. Once again, resiliency. So you essentially get the idea that security as has been practiced in the traditional environment doubly applies, but with extensions to integration of the new systems of engagement in the front-end workloads. So Dieter pointed this out. This is our point of view. In order to get to the right infrastructure, you need to understand the workloads. Design for data, bandwidth, access latency, continuous data load, use of technologies like grid scale storage, as well as flash. Defined by software, integration of private as well as public clouds, and more importantly, in getting the systems of engagement, the front-end systems connected and integrated with the back-end systems of record with the kind of qualities of service, availability, security, as well as resiliency that are very critical. And the ability to build them with open standards-based interfaces so that you are using the pull from what the industry is doing rather than the push from your capability as an individual vendor, and that becomes a powerful way to create value. So the last one is, we have kind of gone through this, and we do have a broad variety of systems infrastructure, the mainframe, power systems, pure systems, System X and storage systems, a very broad portfolio of infrastructural technologies. The question is, and we do know what is involved. The question is, how can we help you? How can we collaborate with you? And how will you be able to leverage this infrastructure to optimize our mutual clients' revenue, profit, and competitive advantage? And how do you define a consistent end-to-end IT infrastructure strategy? Because the point that I made from the Institute for Business Value is you need a consistent strategy. It is not just a point set of technology. It is not a matter of throwing a bunch of seeds and say, we have a garden. you got to do some homework before you can get to that. And partnering with us, we would love to be able to do that, and we want to know how we could do that. Thank you.